Welcome everyone. In this video lecture, we will solve or think about the effect of finite output loop gain, that is our A. Okay. For example, I am saying this operational amplifier having gain A in an inverting amplifier. So ideally, what we are taking, ideally, ideally we are taking the open loop gain, that is our A value is infinite gain. Okay, but we have to do it for the finite open loop gain. Okay, so we have to do it for finite output loop gain. So before that we will think, if this one is infinite, what is the gain? So if it is a infinite, so as we know, this value v naught is simply minus rf by r1 times of vi. Okay, this one is very standard formula, we can say. We can also derive this formula, it is very simple. Okay, but we have to do it for a this a. Okay, this we have done for by considering a value infinity. Okay, so what we are doing means, for a infinity, okay, this is 0. So this potential due to virtual ground, this we have taken as 0. Okay, 0 volt. So this one current say I1, and this current will be also same. Okay, I1. So there will be no current in this one. So I am just going to prove this one. So I1 will be Vi minus 0 by R1, and similarly this I1 in the resistance R1 will be 0 minus V naught by Rf. Okay, is it clear? Means this one, this current in RF. Okay, I am just speaking. This is a zero potential, and this one is our V naught potential. So this current I1 we have made, and this one in this resistance R1. This having the VI potential, and this having 0. So this current will be say I1. So I1 will be, okay, once again I am writing same thing already written. So this I1 is Vi minus 0 by R1, and this I1 in this one also the same current, 0 minus V naught by Rf. Okay, I am again highlighting this one. Okay, so both are same. Means in case of infinite gain, okay, open loop gain is infinite. So we can very simply, we have find this, here I am writing Vi by R1 equals to minus V naught by Rf, by considering this one equation 1, say equation 2. Okay, so V naught is simply minus Rf by R1 into Vi. Okay, so this we know. Okay, for the this we know. Okay, this we know for a value infinity. We did for the infinite. Okay, virtual ground concept, this should be 0. And how the virtual ground concept we can say, means it is very simple. Means the a value will be v naught by v plus minus v minus, we can write. So a we have to make it infinity, so v plus minus v minus will be 0 to make a value infinity for infinite gain. So v plus is same as that of v minus. So that's why this one is a concept of virtual ground. Okay, virtual ground. Okay, means this potential will be same as it. So that part we did. Okay, now we have to do it. Ideally we have to take this as a infinity. Okay, now we have to do it for the finite one. Okay, now what we are doing, we are taking a value as a, means finite open loop gain. Then what should be the expression we have to find? Finite open loop gain. So for this purpose, again we have to take here we are taking the infinity value. Okay, in ideally we can say. So now again what we will do, we have to put the same figure here. Okay, but now what we are doing, we are writing this is some value, say a. Okay, here a infinity, so v naught minus r by r1. Okay, now this one is the thing. Okay, so now what we can write, this a value is some finite value. So a value is nothing but simply v naught by this potential. So what we can write, v plus minus v minus means this potential. Okay, potential across this side. Okay, v plus minus v minus. Okay, so what we will do, so we can easily find this v plus is grounded. Okay, so what we can write, v naught and v plus is grounded, so make it 0 minus v minus, because v plus is grounded. Okay, I am writing v plus is grounded. So we have to find the potential at this side. Okay, so v minus is nothing but simply minus v naught by a. Is it okay? Means the potential initially in this case both are 0 due to due to virtual ground concept. V plus, we have to make it infinity. Now our a is some finite value. Okay, this one is some finite value. So the at this point potential at this point will be our, say, v minus will be minus v naught times of a. Is it okay? Now this point is clear. Now we can easily solve. So for the finite output, finite open loop gain, the this potential will be minus v naught by a, because this one is grounded, so this potential will be simply minus v naught by a. So now what we have to do, means I'm just making the circuit first. R I am okay, the, and this potential is, say, v naught. Okay, and this one is v minus, and this one is our vi. Okay, this one is r1 rf. Okay, and now this v minus is our minus v naught by a. If we know, and all current will go like this, I1, and this current will be also I1. Okay, there will be no current in this stage. Okay, so now we can easily find. Okay, now this I1 can be written as vi minus v minus by r1. Is it okay or not? Very simple. I1, this I1 will be vi minus v minus by r1. So vi, make it vi minus v naught by a, and minus of minus vi, so minus minus plus. Okay, or one more line, r1. So I1 equals to vi plus v naught by a divided by r1. Okay, so this one is okay. Means how we have find this value? Very simple. This I1 will be this current vi plus v naught a by r1. Okay, so this one is the I1 value we have calculated. Very simple. Okay, this I1 we have calculated by using this formula. Okay, now I1 is known to us. Now we have to do it for this one is also I1. So for this one, what we will write, I am writing here. Okay, make it closed. This one for the a infinity, here I am writing. Now this one is Rf, and this one is v minus, that is our minus v naught by a, this point, and this point is our v naught, and the current in the circuit is same as that of I1. Okay, so again I1 can be written as minus v naught by a minus v naught by Rf. Is it okay or no? RF, or we can write it, we have taken RF. Okay, yeah, RF. Okay, minus V naught by A minus V naught by RF. This one is the, okay. So now one more line we can write. If you take minus V naught common, one can also write 1 plus A times of ARF. If you solve this one, minus V naught 1 plus A by A times of RF. Okay. So this one is the another equation. So I am saying this one is the equation number 1, equation number 2, and both are same. Okay, so 1 equals to 2. So if you solve this one, it will give the expression between Vi and V naught as a function of A. Okay, so the function will be Vi plus V naught by A by R1 equals to minus V naught 1 plus A by A times of Rf. Okay, now we have V naught Vi, we have to find V naught by Vi. Okay, so what we can do, what I am doing here, okay, one can write Vi plus V naught by A, okay, and R1 we have to put here. So one can write minus R1 A times of Rf V naught 1 plus A. Okay, simple. This R1. Okay, next line I am writing here. Then what we can write, minus Vi. Okay, why I am writing minus Vi? Okay, because if you take this one in this side, okay, or better to do like this. Now what we can write, V naught by A in this side is there, and put this one in this side. So R1 A Rf V naught 1 plus A, and if you put this in the this side, so it should be minus Vi. Okay, now in this one we can easily say our V naught, we can make it common. V naught, one can write in both term, V naught is common, so 1 by A plus R1 by A times of Rf 1 plus A minus Vi. Is it okay? Okay, actually we have to find the V naught by Vi. So our V naught by Vi, V naught by Vi is nothing but simply minus 1 times 1 by A plus R1 times of ARF 1 plus A. Okay, in simple calculation. Okay, now we will solve. Then we can write, I am doing step by step. I can write directly also, but we have to go with the process. Okay, I am writing minus 1 common, and then one more line I am writing 1 by A plus, one can write R1 by Rf into 1 by A plus R1 by Rf. Okay, simple calculation is there. R1 by Rf into R1 by Rf into 1 by A, 1 by A. Okay, now what I am doing, minus 1 if we take common, and if we take also common, minus R1 by Rf. If we take minus R1, sorry, R1 by Rf common, one can write 1 plus A plus, what we can write, Rf by R1. Okay, in this one, Rf by R1 into 1 by A. Okay, here I am writing. Once again, V naught by Vi, same thing. minus 1 by, if we take R1 by Rf, why I am writing, it will be clear after few seconds, few minutes, plus Rf by R1 into 1 by A. Everything will be same. I am taking, writing like this. So now it can be written as minus Rf by R1, because like this. Okay. And what we can write, 1 plus, okay, R1 by 1 plus this one, and then what we can write, A plus Rf by R1 into 1 by A. Okay, here Rf by R1 will be common. Okay, Rf by R1 will be common, so 1, then 1 by A. Okay, sorry, this should be 1 by A. There is a mistake. Okay, here I am writing the same thing, but Rf by R1 will be common, then 1 by A. Okay, 1 by A, Rf by R1, and it should be 1. Okay, Rf by R1 common. Okay, so it should be 1, 1 by A. Okay, it should be 1 by A. It should be 1 plus 1 by A plus this 1 by A. Okay, means Rf by R1, we have to get the Rf by R1 plus Rf by R1 into 1 by A. Then Rf, this should be cancelled. So we can write like this. So minus Rf by R1, 1 plus 1 plus Rf by R1 into 1 by A. We can also take 1 by A common from both the sides. So our final expression is like this. Very simple. Why I have written like this, I will tell you. Because now if we consider, this one is the expression with a finite gain. Okay, finite open loop gain. So if we say, if a tends to infinity for infinite gain, this term will be 0. So v naught by vi will be simply minus Rf by R1. Okay, means when a approaches infinity, the v naught by vi, or we can say this as a overall gain. Overall gain will be simply minus Rf by R1. Okay, and if we have to minimize the dependence of closed loop gain, means v naught by vi, v naught by vi, we can say closed loop gain for the timing, closed loop gain. Okay, we have to minimize this closed loop gain, g we have to minimize. Okay, we have to minimize the this closed loop gain. Okay, over the open loop gain, for the this open loop gain a, so we have to take 1 plus Rf by R1 value will be very less than a. If we take this value as smaller, then we can minimize the open loop gain. So this one is the expression v naught by vi minus Rf by R1 by 1 plus 1 plus Rf by R1 in bracket 1 by a. So in this concept, we will also solve one numerical. So this one is the final expression for the gain, closed loop gain, when we are considering the open loop gain, which is finite. A finite, when we are considering the finite value, we are taking this one is the output, means output by input. But when we are taking a as infinity, it is simply Rf by R1. So this one is the thing, means only thing we have to consider this v minus this voltage for the finite gain, it should be minus v naught by a. Then our analysis will be very simple. You have to go step by step. Then we can find this v naught by vi equals to minus Rf by R1 1 plus Rf, was 1 plus Rf by R1 into 1 by A. So this one is the expression when we are considering the finite open loop gain. Okay, finite open loop gain. Then this will be the expression minus R by R1 1 plus 1 plus R by R1 into 1 by A. This is very simple. You have to go step by step and you have to solve. Okay, means R by R1. Why I have taken R1 by RF common? Because this R by R1. Then it should be simply again 1 plus 1 by A, 1 by A, R by R1. Okay, 1 by A, okay, R by R1. Okay, this. So like that you can see we have derived the expression for gain for the inverting amplifier when we are in the finite open loop gain. So this is all about this uh, presentation. So thank you for watching this video. Thank you.